All right. So if you guys look at this here, my screen, there, this is kind of review, and it's not. So scientific notation, and you're either making big numbers smaller or really small numbers more manageable. So in both cases, you're making numbers manageable. So for example,
To write this down.
you can, or this will be on a video, so you can just watch it again later or write it down later as well. If I'm going too fast, don't sweat it. I'm going to put this on YouTube. So let's say you have 3,200,000. Let's go billion. Yeah, right now, right? So that would be millions. This is billion. So this is 3,200,000,000. So if you needed to put that in scientific notation and compress it down, there's just 3 steps or something like that. It's not much. So the first step is you locate the decimal point. There it is. Next step, you move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. We move it 9 spots. Now in this case, we do move it 9 spots, and I'll explain this in a minute. So you move it 9 spots. And the reason being is you move until you have one single digit, then the decimal place, and then your remaining digits over here. So you want one digit here. That's important for scientific notation. How long does this guy have to use the blower on the side of this house? It's so loud and distracting to me. Anyway, um, so so then we write these numbers down. So 3.2, and we always put times 10, and then how many times did you move it right here? 9. So that's how you would do it. If it was a very small number, 0.000000753. Very similar. You locate the decimal point. There it is. That's step 1. Step 2, start moving it. 1, 2, 3, 4, 5, 6. And we're going to move it 6 times here. And it's going to be 7. And we're going to put the decimal place there, 0.53. And the reason we move it this many times is because you move it as many times as you need it until you have the one digit here and then the decimal place, just like we did here. It's the opposite direction, but the point is you want one digit, then a decimal place. So one digit, then a decimal place. So I got it. Then we put times 10 to the how many times did I move it? 1, 2, 3, 4, 5, 6 times to get there. The only difference is since this was a very small number, we'll put a negative. And that's all there is to it as far as putting them into notation, scientific notation, that's all. Now, engineering notation is different, but almost the same. Engineering notation is almost exactly the same. So let's do this one in, should I do this in engineering notation? No, I'm not going to do this one in engineering notation. I will not. And the reason being is it'll look exactly the same. And so let me do one that's different. Let's do 33 billion and 400 million. Okay, there we go. So 33 billion, 400 million. If I want to put, let's say this was, let's say this is volts, right? That's a lot of volts, correct? So 33 billion, 400 million volts. That's a lot. So how would we put this in engineering notation? Watch the steps. It's very similar. We find the decimal place. There it is, right there. It didn't exist, so we'll add it there. And the only difference is when we move, you can only move by 3s. So watch this. 1, there's 3. There's another 3 there. And then I'm going to move again here. And you're going to keep moving until you have up to 3 digits here. So you could have 1 digit, just like scientific notation, or 2, or up to 3. You're allowed to have up to 3 here, okay? So we move, and just keep moving until you find the spot. So we're going to put 33.4 times 10 to the, and this number here will always be a power of 3, like a multiple of 3. So it'll be a 3, a 6, a 9, a 12, a 15. And how many was it this time? It was 9, right? 3, 3, 3, so 3, 3, so that's a 9. And the reason we do that, folks, there's a good reason we do this in engineering notation. It's because this actually has a name. 10 to the 9th actually has a name. I think it's giga, but let's just double check real quick. Watch this. Let's go to our PowerPoint, and I'm going to slide down a ways to find it. 10 to the ninth is right here, correct? So it is, and let me zoom in so you can see that. There we go. 10 to the ninth is giga. So it actually has a name. And that's why we use it, by the way. So 10 to the ninth is a giga. So you could just say 3.34. You could just say 33.4 gigavolts. That's what's cool about engineering notation, is that we can replace this with the name, because this is the same thing. These are the same thing. So I could just say, you could either say 33,400,000,000 volts, or you could just say 33.4 gigavolt. So I'll do one more example here. Let's go with 1,220. Anybody know where I'm going with this? No? Well, no, not yet. I'm going. I'm doing watts here for sure. So I'm not going to do bytes, but we could totally do bytes and then do gigabytes and all that stuff, definitely. So no, I'm doing watts. So let's put a 1 here. How about that? Maybe I was wrong. 1,021,000,000 watts of power. So let's convert this. Here we go. Let's find the decimal place. We can remember, we're doing engineering notation now, not scientific notation. We're doing engineering notation. So we're going to move by threes only. So we move 3. Oops, that was a terrible little move. Another 3. I still got 4 digits here. So another 3. We keep moving until you have between 1 and 3 digits. So you can have 1, 2, or 3 digits here. So we can have 1, 2, or 3 digits. There's only 1. So the answer is 1.21. And then we go, how many times did we move it? We moved it 3 here, another 3, that's 6, and another 3, that's 9. So times 10 to the ninth. And then we put watts. That's the answer. So you could say 1,021,000,000 watts, or you could say 1.21 times 10 to the ninth watts. But remember, 10 to the ninth means giga, so you could say 1.21 gigawatts. Or if you were like a certain somebody, you might say gigawatts. Anybody know now? Anybody know my reference yet? Hello? Geez, you guys go to Whittier High School. Yes, thank you. You guys go to Whittier High School. You guys go to Hill Valley High. I mean, so you guys should know that in the movie Back to the Future, Doc's like 1.21 gigawatts. Nothing has that much power except maybe a bolt of lightning. Remember? So anyway, I just thought that would be fun. So 1.21 gigawatts, which is the same thing as 1.21 times 10 to the ninth watts, or you could just say, if you want to say the whole thing out, 1,210,000,000 watts. All right, and let's do one small one, 0.000000074. Let's just do volts. Volts right there. Okay, this is a very small amount of volts. But let's just read this. So let's go. This is engineering notation. So we move by threes. There's 3. There's 3 there. And there's 3 there. And I can't move again because remember, once I put the... Oh, wait. Actually, I do. I need to move again. Because you don't want point something. Remember, we need up to 3 digits to the left of it. So I got to go again. And I'm going to put it here. And so there's going to be a 0 here. We're looking at 740 is the answer. Oops, that's a 40. 740, and we moved it 1, 2, 3, 4. So that's, what's that? 3, 6, 9, 12 times 10 to the negative 12. Remember, we put a negative when it was a really tiny number to begin with, so we put a negative, and volts. And that's the answer. Now, if you want to do it exactly with the name, we can do that right here. What is 10 to the negative 12th? That's a really tiny number. That's a pico. That's even smaller than nanos, right? So millis are small, micros are even smaller, nanos are smaller than that, and then picos are even smaller. You could go smaller to femtos, but we probably won't go that small here in this class. So technically, that's 740. What was it? Picovolts. All right, that's a real tiny amount of voltage there. All right. So that's. I hope that explains the difference between scientific and notation and whatnot. So I want you guys to see that in your worksheet right here. This is today's worksheet. That express these in scientific notation. So the answer here is going to be 3.56 for sure, because you're going to move the decimal place till there's only one digit right. I can't highlight it, but only one digit right here. Same thing here, here, and here. Here, we're going to do them in engineering notation. So when you put your answer here, definitely it's going to be times 10 to the 3 or 6 or 9 or negative 9 or negative 6, right? So it's going to be powers of 3, okay? This one, you can just ignore it. Come on, it's 847. Who's going to put that in engineering notation? I mean, you could just put 847. That's easy. All right, next. Express each of the following numbers using the appropriate SI prefix. Don't forget to retain units. So that's pretty much what I've been doing as well. So let's do one real quick, okay? Let's do this one right here. Got it? So how many zeros do we have here? We have 0 point, and then 1, 2, 3, 4 zeros, right? Let me zoom in a little bit in case you guys can't see that. So we have 1, 2, 3, 4 zeros, and then a 4, 7. Okay, let's do that. So let's go new, and then so it's the 0.0000. There was 4 zeros here, then a 4, 7, and then they had an F, and that's farads. That's a unit of capacitance that capacitors use, and we'll learn more about that later in the class. So they want to put this with the proper prefix, and I'll show you what that means. So you'll definitely have to put these in engineering notation, okay, this section. So let's do that. Let's move by 3. That's not going to cut it, okay, because we don't want 0.047, so we need a real number here. So let's go another 3, and that will work. So it's 47 with a decimal point, right? So we're done. 47 times 10 to the negative, because this was a small number. We moved 3, then we moved another 3, and we put the decimal place here, and the answer is 47 here. So we put that here. And it's times 10 to the negative 6 farads. So we're not quite done, because the question was, it said, if you look, it says to express each following with the number with the appropriate SI prefix. So for that, you'll have to, right here, there we go. You'll need that chart on the PowerPoint in your assignment. So if you go back to your PowerPoint, there's that chart here. Come on. It is down there a ways. It is in here somewhere. There it is. Here we go. And we're looking for 10 to the negative 6, right? I do believe, if you want to look, yep, 10 to the negative 6. And that's micro. Or you can use this symbol here, the little weird U symbol, right? It's a Greek symbol. So, so the answer is 47. My gosh, my pen's messing up. 47 microfarads. That would be the appropriate answer, because I used that little symbol there. If you want to use one symbol here, then you can use the one symbol here, so it's just microfarads. And what does that mean? That means 10 to the negative 6. We looked it up. You could also write it out in full if you know what F stood for. You can say microfarads, like that, if you want to do that. But this is easier. Just put the symbol and then this symbol. So if you look real quick here, just put the symbol. You don't need to put the word. Since they're just putting the symbol for the unit, just put the prefix right here in front of it. I'll do one more with you guys real quick. In fact, let's see if I can Classroom. Let's see if I can go to Google Classroom real quick here. And go to your class, and so I don't have to keep going back and forth. I'll just open that assignment. So that's classwork. I'm really zoomed in here, aren't I? And then here it is, scientific engineering. This is your assignment for the day. And let's do this one right here. So the unit is Hertz, HZ, and the number is 175, then 1, 2, 3, 4, 5 zeros. Okay, that's easy to remember. 175 and 5 zeros. 2, 3, 4, 5. There we go. That's the number. And the unit was hertz. Hertz is just a unit of frequency, like how often something happens. So whatever this is measuring, this is, what is this number? That's thousands. 17,500,000 hertz. So in other words, 17,500,000 things per second, frequencies, maybe vibrations per second or whatever it is. All right, so let's do this. Engineering notation first, of course, because we're doing prefixes. So there's the decimal place. If you can't find it, it must be right here. And we move 3, and we move 3. Notice they're pretty much wherever the commas are. And we're done, because we have up to 3 numbers here. We have 2, so we're good. So 17.5, the point's going here. And then times 10 to the, we moved it 6 times, 3 here, and then 3 here, so 6. And then hertz. Except we're not done because it said to put the prefix. So if you go back to our assignment, you'll see that 10 to the 6th power is right here, and that means mega. So just a big capital M. A big capital M will work, okay? So the answer is 17.5, and replace this with the prefix, and then put the HZ. Megahertz. 17.5 megahertz. Okie dokie. And then what's the next section to? Converting the following numbers. This is the last part, right? Yeah, so the other part's just conclusion. This is the last part. And they want you to turn picofarads into microfarads. And they want you to turn 2.7 megahertz into kilohertz. Okay? Now, how do you do that? Well, first off, let me move this right here, so they're right next to each other. And let's do that real quick together. So 6,800 picofarads. We're going to go to micro. So there's going to be a lot of these and less of this. So as you go up, the number should get smaller, okay? I'll just tell you, as you go up this way, up the chart, the number will get smaller. And if you go down, the number gets bigger, okay? So just remember that. So, and I'll show you what I mean by that. So notice we're going from pico to nano. Let me just double check I was right about that. Yeah, pico to nano. No, we're not. We're going pico to micro. Pico to micro. So that was a U, right? So we're going pico to micro. So that's a negative 12 to a negative 6. So that means there's a difference of 6. 12 and 6, if we subtract them, that's a difference of 6. So this number right here is going to become smaller by 6 spots. Just remember that, smaller. Remember, as I go up, that chart, the number gets smaller. So let's go and do that, 6,800. So let me get a new page here. No. 6,800, I think it was picofarads, and they want to go to micro. So notice we went from a negative 12, that's a pico, to the negative 6, so that's going to be a move of 6, and the number always gets smaller. As you go up the chart, you get smaller. So it's a smaller. Then obviously the opposite, if you go downward, you get bigger. So we're going to go smaller by 6, so here we go. Put a decimal place, and let's go smaller by 6. 1, 2, 3, 4, 5, 6. See how small the number is now? 0.0068. And you could drop the rest of the zeros, or you can keep them, doesn't matter. So the numbers looks really small now, right? But that's how many microfarads you would have. That's the same thing, by the way. You could say this many picofarads or this many micro. Let's look at the other one. The next one, real quick. So we're going from megas to kilos. Kilos, not kilos. What? Kilos. That was my old gang name. Just kidding. All right, so so we're going from megas right here to kilos. So if we go smaller going up, we're going to go bigger going down. So this number is going to become bigger. By how much? Let's see. This is 10 to the 6. This is 10 to the 3. So only a difference of 3 decimal places, okay? So we 6 to 3. That's going to be 3 decimal places. And remember, we're going down, so it's going to get bigger. So just remember that. So let's write the number. What was the number? 2.7. So the number here is 2.7, and that was mega something. What was it? Megahertz? I think it was megahertz. And they want to know how many kilohertz that is. Well, mega and this, remember, mega is 10 to the negative 6, and kilos is 10 to the negative 3. So that's a 3 difference. So 2.7. And remember, we're actually going down the chart so it gets bigger. Remember? I told you if you go up, if you go up, you get smaller. But we're going down the chart actually, so even though it looks like I didn't right here. But anyway, so we're getting bigger by 3. 1, 2, 3. Dozen places going here. We're going to add zeros wherever the blanks are. 2,700 kilohertz. And this is the same thing as this. It's the same exact value. All we're doing is changing the prefix. And I'll do one more and that's it. And then you guys can do the rest yourselves. Let's do this one. Giga to mega. Giga to mega. So let's figure out where we're going. So giga to mega, we're going down the chart. And down means bigger. Up means smaller. So we're going to get this. So this number is going to become bigger by how much? Giga 9 to 6. So it's going to be a difference of 3 decimal places. See? 9 is 6. Then since we're going down, it's going to be bigger by 3. So let's do that real quick. 4.24. 4.24 is the number. 4.24 gigahertz. And we're going to megahertz. And that's going to be 3, and we're going to be bigger. So 4.24 by 3. To get bigger, we're going to move this way. 2, 3. We're going to put it here and fill that 0 here. So 4240 megahertz. So either you're moving the decimal to the right to make the objects bigger, or you're moving the decimal place to the right to make them smaller. So as a reminder, if you go down, you get bigger. If you're going down the chart, you're going bigger, which means you're moving the decimal place to the right. And if you're going up, you're going smaller. And that means decimal moves left. And how much you move just depends on what 2 spots are moving from. That's all. And just figure out how many sets of 3s that is, and that's it.